Hello, and welcome to this webinar on AI and how it can add value to the mining value chain. My name is Lotta Such, and I will be your host this afternoon. It's a 2-hour session with some very short breaks that you can go and have a coffee. And I would like to start to present Swedish Mining Innovation, the organization behind this event. Swedish Mining Innovation is one of 17 national innovation programs that we have in Sweden. The aim of our SIP is to enable and facilitate innovation and development in the mining sector. We support research, innovation, education that develops sustainable solutions for the mining and mineral sector. And we do this through a number of initiatives. We support innovation projects with an annual open call, and this call opens in May. So keep your eyes open for this. We have strategic projects and a PhD network. We arrange meetings, workshops, and webinars like today. We have an innovation idea competition, award, and quite a lot of internationalization and outreach activities. We work with sustainability through the value chain, from exploration, resource characterization, mining, to reclamation and social acceptance. And with a vision of a world-leading mining and mineral producing industry, contributing to a sustainable society. So we have Federico Pecora with us to start. And Federico is associate professor in computer science with Örebro University, and he founded and leads the multi-robot planning and control laboratory. His research interests are at the intersection of artificial intelligence and robotics, focusing specifically on constraint-based reasoning, automated planning, and search techniques for hybrid reasoning. Most of his recent work deals with the use of these methods for plan-based robot control, multi-robot coordination, and the integration of these with robot motion planning and control. And you lead several research projects in collaboration with Swedish companies, including Epiroc, LKAB, Volvo, and Scania. So welcome so much, Federico.
Thank you. Thanks for the introduction. So if it may please the audience, I'd like to give a little bit of an informal highlight of the things that we do in our lab and how these relate to problems that are interesting in mining in particular. Mining as being one example of industry that involves heavy vehicles moving lots of stuff around and then having to maybe use many machines to do these kinds of things all together in a confined workplace. This is why the mining sector is really interesting for my lab, the multi-robot planning and control lab, where we focus on multi-robot systems. My lab is one of the 5 labs in our Center for Applied Autonomous Sensor Systems. And as such, it is one of the labs, or it looks at a certain subset of the problems that are involved in creating autonomous robots and autonomous systems. Many of the other aspects are analyzed in the other labs, and in particular at the Center for Applied Autonomous Sensor Systems, we pride ourselves of having extremely deep cooperations between these labs. And that is why we can go all the way into sort of deep into application areas and realize things that are relevant for the industry. So mostly speaking, or by and large, you could say, let me see if you can see this properly. In our lab, we focus on building multi-robot systems that act competently in the real world, and the acting competently and in the real world are fundamental keywords here. The real world always inspires us, and from the real world, we gather use cases and problems from which we derive research questions that we then answer via research projects. So in particular, the way we do this is we really try to involve the companies, and most of the research grants that fund my lab are or have strong industry participation and co-funding. The mining sector is a large part of this. In fact, it involves, of course, Epiroc, more recently Alcoa AB, and the Some Academy, but also other actors related to mining, Volvo Construction Equipment, Scania, and others. So you will see later when you talk to Ola, or when Ola gives a little talk, and he's going to talk a little bit about a problem that Epiroc came to us with many years ago. He's going to show you the cool videos of the results that we've achieved together. I can tell you about the problem. The problem is how to drill holes in an open pit mine in the fastest way possible. It seems simple, but actually behind this problem, so the reason, by the way, for drilling the holes is that then everything is blown up and the rock is taken out and metals, for example, are extracted. So it seems like a simple problem, but it becomes very difficult when you put many machines in the same in one picture. So obviously, the more machines drill holes, the faster it is, supposedly. And when they came to us with this problem, it took us, this generated a research question that we tackled for 2 years at least. And it ended up in a really nice, some really nice results, both from the theoretical point of view and from the point of view of the exploitation. We filed patents together with Epiroc, and this is a sort of a living legacy of this project. As I said, Ola is going to show you the videos. I'm going to show you why it's difficult and how we solved it, or give you an intuition. And the reason why this problem is difficult is that whenever a machine drills a hole, this hole becomes a pile, because 20 meters of stuff has to go somewhere. And this pile makes it impossible for other machines to go over that area. And so this inevitably leads to the issue of deciding when to drill things, in what order, by which machines. In fact, even just one machine will have trouble not locking itself into a corner. And this shows you in this animation, I'll show you how we solve this problem. We solve this problem via AI techniques that are called search techniques. And we blended search for possible motions with search for possible sequences. And so we had to do something like in this animation, you see when a machine drills, it leaves a pile that becomes an obstacle. So we had to figure out in what order to drill these holes and how to move around the holes in the piles that have been drilled. And this is a difficult problem. And in this animation, we show one solution to this problem in this particular case. But these open pit mines are composed of hundreds of holes. So you can imagine how big a problem this is. As Ola will be telling you, the techniques that we study here in Örebro University, and the particular AI techniques that we study here, are particularly well suited for this kind of problem. So, of course, this is not the only problem we've solved together with the industry. We've looked at many problems. We've looked at many application domains. Application domains in mining are one example, but the similar techniques as the ones we've developed for machines, for mining machines, are applicable also in other situations. For example, automated warehousing. So if you have to send forklifts, autonomous forklifts around in a warehouse to pick up goods, well, there's obviously the problem of computing the motions for these forklifts, and also of sequencing the motions of these forklifts and making sure they don't collide with each other and they don't lead to deadlock situations and so on. A similar problem as the one I spoke about just before. Similar problems exist in quarries. With Volvo CE, we've been looking at the issue of automating multiple haulers in gravel quarries. And similarly also in production scenarios, assembly scenarios where we have robots bringing pieces to assembly lines, and we may have many of these robots. So the experience that we've gathered throughout the years with all these companies, and I would say in large part thanks to the mining sector and all the experience they've given us, we have obtained general solutions to these problems that apply to many and that we can apply in different areas and in different application domains. And one of the solutions is the coordination ORU library, which is something that I started developing in 2017, and I've since built a team around. And it is one of the main things that we look at in my lab. I won't go into details here, of course, but basically what this allows us to do, let me just go back one here, is things like this. So here you see another mining example. In mines, it's really important that machines, of course, give way to each other, like in any scenario. But in mines in particular, you have long tunnels. And so when you have long tunnels, it's really important that you allow machines to follow each other in these tunnels when they're going in the same direction, and not to do so when they're not. And this is this complicates the mathematics behind this coordination problem a little bit. So the techniques that we've developed are among the first in the world that don't require you to manually discretize the environment or just chunk the environment up into pieces in order for this to happen seamlessly. And so with the methods that we've developed, the two situations shown in this video are equivalent, so to speak. And the behavior that you obtain is smooth and exploits the ability to use space. We've developed this into demonstrators that we've shared with our partners like Epiroc and Newcrest here, where we show how this kind of coordination is useful in underground mining, where we can coordinate and decide the tasks that tens or more vehicles have to do when they have to pick things up from rock up from draw points and put it into a dump point. Here, this is really showing the kind of flexibility of the approach. Another key point here is that not having to decide or to divide the environment up in a predefined way lowers the deployment overhead. So it makes deploying the system much cheaper. You don't have to install infrastructure in your mine. You don't need to worry about traffic lights. You don't need all this overhead. You're more flexible in exploiting the space. A similar thing can be said for. Sorry, I went up further. Can be said for another project we had with Scania, where we looked at how this applies to bus depots. This is an example of a bus depot in Leipzig, where this is a simulation, of course, but you have buses coming in after a day of work, and the idea is that they need to be coordinated in when they're dispatched to the various things they have to do, for instance, maintenance, fueling, parking, and so on. And potentially, you can have very complex situations, like, for example, this one that's about to show now, where you see buses going to and from many different places in a seemingly disorganized manner. And how do you make sure that the system doesn't seize up and that buses start to block each other? This is the challenge. And this is another of the features of the approaches that we've developed, that they guarantee, and we've written theorems about this, they guarantee the fact that the system will always be deadlock free. We've deployed our systems in many situations and with many types of robots. As you can see here, these are just two examples in labs across Sweden. The bottom right is in our lab. On the top left, you see a lab run by Volvo CE in Skövde. So the system is being used by others as well. We like to develop things that can be used by others, not just our industrial partners, but other academics. I think they're using this in Chalmers as well for some project work. I'm going to skip ahead and just show you an example or a sample of something else we do in the mining sector that is very interesting, I think. And it's this. So of course, when it comes to moving stuff around, moving ore, rocks, and so on. Transport machines are important. And in underground mines, for instance, it's very useful to automate them and to remove the driver from the cab. And so it makes sense to have robots in these situations. But there are other types of robots that are very meaningful in mining, in particular, serial manipulators and articulated robots like these are relevant, for instance, for drilling holes in walls. So typically, in a mine, you will have something like this. If you look at the image on the bottom left here, you have what we call a boomer. This is a machine that Epiroc builds. They call it a boomer, in fact. It has up to 4 arms with drills in them, and the arms have to drill holes in the wall. Also here, there is the problem of ensuring that arms can move in a smooth way across the shared space. And this is not necessarily easy. And the state of the art, before we came along and developed a novel approach, called for, again, discretizing or chunking up the environment into zones in which one arm could operate and then the other one could operate after the first one had finished, and so on. This was all clunky and difficult and inefficient. We developed continuous motion coordination methods for this purpose. We tried it in the lab, as you see here, and then we deployed it on a simulated Epiroc machine, as you see here. This is stuff that we demonstrated to Epiroc a few weeks ago, in fact, where you see that we are showing how our algorithm can dispatch tasks to these arms. These arms don't have to care about each other in the sense that the algorithm will make sure that their movements are synchronized properly. And we are also robust to contingencies. And this is important in this application because you never know how long it's going to take to drill a hole, and you never know what's going to happen when you're drilling. So one task could take a long time. So you can't predict when that task will be finished. And hence, you need to dynamically allocate tasks to arms and do things of that sort. So these were just a couple of examples. I think I stayed within the 15 minutes, a bit short. I can talk more, but I think it's best to talk less and leave the floor open to questions. I'd like to thank all the collaborators we've had. All of this happens because of the people in my lab. The final outlook I have is that really autonomous systems are interesting because they bring flexibility to the industry, yes, but they're interesting for us because they pose real problems, challenging problems. And in particular, I think the future holds the next challenge, where that is in teams of robots working with and for humans. So in all of these systems that I've showed you, typically it is assumed that the robots are isolated from humans. So there are no human-driven machines, there are no human operators in the vicinity of the robots. These are physically separated. This is not always possible. And that's, I think, the next challenge. And it is one of the challenges that we're looking at in cooperation with several of the companies I mentioned, including Epiroc, in a new project called Team Rob. So that's it for me.
Yeah.
Hope it was enough.
Yeah, I think so. So if anyone has a question for Federico, please just write it in the chat, and he will be here for another.
Yeah, I have to run it too because I'm teaching, but another half hour.
Yeah. We will invite Håkan Tini to this discussion as well. I was just thinking, Federico, do you have like a dream AI application for the mining industry that you would like to develop?
A dream application?
Yes.
You mean a problem that I'd like to solve? Yeah, well, my dream would be to be able to see one day completely mixed fleets of human-operated, tele-operated, autonomous machines in a mine. I don't think we're going necessarily towards full automation of everything. I think it's important to be able to automate step by step, but also it may never be interesting to have everything autonomous. There will always be a need for some human driver or decision maker or someone who comes into the system to, you know, change a drill bit or whatever. And I'd like to see AI that is capable of dealing with all of this. This is the challenge, I think, And I'd like to see a real good example from the mining sector where this is necessary.
Great. Thank you so much.
Thank you.
So please, Håkan, you can come into picture here.
Should I go out of picture? I guess.
Yeah.
Great.
Is that stop screen sharing or this computer? Or you can stay here.
Up to you.
Yeah.
That's why I asked. I don't know if it's a discussion now.
Yeah.
Or... Okay.
So it will be a discussion.
Oh, okay.
Yeah. And Håkan Tini, welcome. You're from LKAB. Håkan has a long background in the mining industry, and he has held various positions in the areas of automation, autonomous vehicles, IT, and cybersecurity. He now works with responsibility for LKAB's IT security, but is also involved in LKAB's digitization project and participates in the technical management of the project Sustainable Underground Mining.
Thank you.
So, welcome, both of you. And my overall discussion here is how can AI improve the mining sector? How can we benefit from AI applications, and how to make it not only a project and an application here and there, to make it like a whole fleet of AI solutions for the whole mining value chain. It's a big question. Yeah.
But I can start. I think Federico was in on the last point to make, that the mixed situation with autonomous vehicles driving around, and then you have manual operations you have to do. I think because when you automate things, it's big machines, it's safety, you can't do maintenance work in same areas, and that will every time you put in people in the area, you will decrease the productivity because you have to stop the automation systems. So mixed solutions, more things you can do without stopping the autonomous system. That will increase the productivity. And also, if you look on from our company's perspective, the future, we try to decrease our CO2 footprint. So the traceability of the production, so you can mark every portion of the production to the end customer. You can tell exactly this analysis in the mine and connect it to this tonnage. So when the customer buys something from us, he gets a certificate. Okay, this is the footprint, the environment footprint of this ton of iron ore you buy from us. I think that's a new thing this will be very important for the future. And I think AI can help us, because traceability and trace products in a continuous flow is super difficult. So I think that's an interesting area for the future.
What do you say, Federico? What would we need in order to get there?
Yeah, that's a very good observation. And I can speak to both things you said. I think for the first one, there is an inadequacy of AI and robotics methods today that we're working very actively on bridging. So we want to bridge that gap. But basically, robotics and AI systems today are not capable of dealing with the human intervention aspect. And we fully recognize that this is a production issue and a productivity issue. Another example I can cite is we were working with Volvo, and they were telling us that it's important to always guarantee that there's a hauler underneath a producer of gravel, and this producer was a conveyor belt spitting out gravel. Because if there isn't, then the gravel falls on the ground, and you got to send someone in to scoop it up, and you got to stop the process. And even just dealing with this was a difficult issue. Our AI methods were inadequate. We had to develop new ones. And speaking of productivity, this leads into your second point, which I think is also really valid here. because productivity is, as far as I understand, managed at very high levels of abstraction. So you optimize. There's certainly some optimization going on as far as I can tell, but it is with respect to some geological constraints, maybe, and with respect to, at the end of the day, very rigid timetabling of machines that are driven by humans, and everything is rigidly separated. And so there's some basic inefficiencies there that make your high-level optimization difficult. And optimization can be with respect to increasing your outcome, so your profit, but it can also be optimization with respect to achieving a climate goal or some kind of emissions goal, or a combination of both even. So you could do multi-objective optimization and consider both aspects. But all of this works well if you can control all the way down. And this is what we're lacking, the going deep. So the making high-level decisions and then connecting them to the low level without manual decisions made in the middle, managers using an Excel sheet to make shifts and stuff like that. So very interesting points that are challenges for AI today.
Yeah, one thing with underground mines, it's a lot of events. You can't plan for them. It's high-level planning. As soon as you deliver the plan, it's old because it's a lot of events happen. So you have to take care of them. Mm-hmm. So I agree with you that like full dynamic planning, you have to, whatever happens, you have to replan the resources all the time for the short time. That's also will increase the productivity.
Yeah. Mm-hmm. That's something, if I may, that's something that Ola might tell you as well, because when we developed that system that I showed you earlier and that Ola's going to show you a video of later, that was one of the requirements that, machines break. So you may have a plan, but you got to be able to take the machine out when it breaks. Or maybe the rock that you're drilling is harder. So it'll take 40 minutes instead of 20 to drill the thing. And this has a knock-on effect on the rest. So there we had to, in fact, look at flexible scheduling techniques that used time windows and some limited form of replanning on the fly when things that are bigger, like machine breaks, happen.
Yeah, but even in normal production, if you're loading from one draw point and suddenly you get a very big boulder, you can't handle it. You have to blast it.
Right.
Then you have a replan. Where will this machine go load during? And then they have the manual work. If it's an autonomous machine, you have to stop the automatic system, blast the big rock, and restart the system.
Yeah.
But in any case, you have to replan. And even how good you are on maintenance, that doesn't matter because you can't predict that this is a very big boulder on the draw point that's coming out from the wall. Yeah.
Oh, that's interesting. And if you had autonomous machines that can truly reconfigure themselves on the fly, unlike the current industrial practice, then you could already do something. So even without involving humans, if your autonomous fleet could rearrange itself in response to this, that would already be an advantage.
Yeah, and the safety system can reprogram it. So the loading machine go to a new draw point, and then you can put in manual operation or other autonomous equipment handling the problem.
Right.
But to reconfigure a safety system, it's difficult. So it's challenging tasks. But if we can solve them, then we will increase the productivity enormously and the flexibility.
Very interesting.
Yeah, I think you will come into this when you present a little bit later, Håkan, on how little technology it is and how much organization it is.
Yeah, to put AI in production.
Yeah.
Yeah, the organization bit could also benefit from AI. I mean, I've been talking about a lot of robotics, but really automated planning is a big part of artificial intelligence. And I have my foot in that research community as well. And one thing that I notice, and maybe they're not going to like me for saying this, but but that community is extremely removed from reality in the sense that you really, it's not ready to deploy an automated system to take over the decision making and the even medium-term planning in operations like mining. I'm quite convinced of that because it's lacking the fundamental abilities to adapt, for instance, to deal with uncertainty and so on.
Yeah, and you need real-time information from every piece of equipment in the mine, all the time if you want to do dynamic pre-planning.
Yeah. So lots of nice problems for us to work on.
Yes, and, the future is bright for you, I think.
The future is bright. Hard, but bright.
So we have to do some rearrangements in the program. So I was thinking, actually, Susanne, if we should take the Kira from Lundin Mining. And after this, we can have a short break and rearrange in the studio a little bit. And I have not seen any more questions for you in the chat. So what did you say? You're here until 2, Federico.
Yes.
So, yes.
Yes, 20 more minutes.
So you have some more minutes to, if you have a question for Federico. But I say thank you to you.
Thank you.
For now.
Thank you.
And I will introduce Kira, who made pre-recording a couple of days ago. And Kira is with Lundin Mining. She sits in Toronto. She's the Director of Operational Technology globally for Lundin. And Kira is an experienced leader with more than 20 years of experience in manufacturing and industrial operations, implementing and integrating operational management systems across different industries, which is a combination of people, processes, and technology. So let's start the recording with Kira.
First of all, thank you so much for inviting me to this conversation today. I'm going to have the opportunity for about maybe 5 to 6 minutes to talk about artificial intelligence and machine learning for Lundin. So at Lundin, we are putting together, first of all, an operating model that's going to define how, or maybe what is the vision that we have in terms of operational technology for Lundin. We would like to do the things in the best possible way from the beginning in order to make sure that we're going to be ensuring the success of the implementations that we're going to be doing in the future. This operating model, it starts by defining what is our vision, what is that achievement that we would like to get in the future for operational technology for all our sites across Lundin globally. This vision is also accompanied by a set of different strategies, and these strategies are going all the way from understanding how operational technology is relevant to the mining industry from the very beginning, going across automation, going across sustainability, going across all those technologies that are going to be able to make us more productive and more sustainable, and on top of everything, safe. For us to be able to develop these strategies, we decided to design from scratch our own, I would say, operational technology framework. And this operational technology framework has been sitting in 4 key pillars. So the first one is how we're going to be making our operations stable and capable from the point of view of stabilizing operations on the first, and then reaching further and further and further on the sense of capabilities for us to be able to reach guidance and to reach operational excellence. The second pillar is all about connected mine, and this is where we're going to be implementing those technologies that are associated with artificial intelligence, machine learning, reinforced learning. This pillar includes the preparations necessary to be able to do an implementation of an integrated remote operation centers, implementations of one digital twin and then implementations of a global digital twin for each of the sites that are going to help us understand what is our maturity in the sense of capabilities and processes, and also going to help us to optimize the operation in a safely way. We have a third pillar that we called the safe mine. And this pillar is all about safety. It's about the implementation of wearables. It's about the implementation of artificial intelligence to predict fatigue, implementation of different kind of technologies that are going to help us to make sure that everybody is going back home safe. And the fourth pillar, it's all about green mine. It's the implementation of technologies, once again, and aligned with the processes and the people, obviously, all of this, to be able to provide the foundations and the basis to make our mines greener. This is all about sustainability. It's all about greenhouse emissions management, gases emission management. It's all about ESG, and it's very closely tied to our soon-to-be announced targets for sustainability. The implementation of this framework is not in a serious way. It's all about interjection and line crossing between one and each other capabilities associated to the pillars. And the implementation of this, it's going to be depending on, for each of the particular sites, what is the technology maturity that they currently have, what is the implementation and the innovation appetite that the site has, and what kind of problems are we intending to solve. So we will not going to be launching global programs all at once for each of the capabilities. It all going to depend on what are the needs specifically for each of the sites, for each of the operations, and also the competencies and the skills that we need to develop around this. Another thing that I should mention is for us to be able to do this implementation of this framework, that we're going to be soon revealing to the public what is the name of the framework. We have developed 14 different programs, and these programs has the main, I would say the main purpose or the main objective of enabling the implementation of the program, but also preparing ourselves to achieve this maturity for the future in the sense of operational technologies. The programs involve all the way from the definition of guidelines, standards, from the technology perspective that will support the procurement process and will support the decision-making at each of the sites. We are also defining programs for designing the operational technology roadmaps for the future with a perspective of 5 years first, and then 10, and then aligning these roadmaps with programs for innovation partnership, for programs associated to communities of practice, change management and adoption plans, and all that. So these 14 programs going to help us to implement this framework. The framework going to help us to achieve the execution of the strategies, and the strategies going to help us. They're going to help us to reach the operational technology vision for the future. At Lundin Mining, we are strongly in love of innovation, but innovation implemented safely first, and making sure that going to make us sustainable for the future. We are obviously interested in testing new technologies, again, in a safe way. We are also interested in participating in programs that going to help us not only grow as a company, but also help our potential partners to grow as well. Understanding partnership from the point of view, not only with the technology companies, startups, but also with governments and associations where we can learn from each other and nurture each other so we can reach the objectives sooner, safer, and in a more global way. So I'm very thankful to have the opportunity to talk to you guys today. I've been asked to provide an opinion around what it is that sense that we understand that how artificial intelligence is going to help the operations for the mining in the future. And I do believe that artificial intelligence aligned with machine learning and reinforced learning actually going to have a lot of benefits for us in the future. It's going to help us to, first of all, to remove the operator from hazardous conditions in the operation, but also going to help us to understand current situations and current variables that we have during the processing and during the operations per se, that probably right now we are not capable of identifying. So artificial intelligence, it's a capability that gonna help us to have a peek in the future, have a peek on what's the future gonna look like, so we can take action now to be able to achieve the future in a safe way, in a proper way. It's gonna help us to improve the operations. It's gonna help us to increase our knowledge on details associated with processing minerals, on details associated to mining safely, on details associated to managing water, reducing the emissions, improving the efficiency of consuming resources such as power, such as energy, and so on. So definitely we are all in for this, but we strongly believe that for us to be able to achieve that and to get there in the proper way, we need to have all the foundations set in the most effective way to ensure that we're going to be successful. So once again, thank you so much for inviting me to this conversation, and I really hope to hear from you soon. If you have any questions, please feel free to reach out. Again, my name is Kira Meyer. I'm at Lundin Mining. I'm the Director of Operational Technology for Lundin globally. I'm located in Toronto, and it's a pleasure talking to you today.
Welcome back. Now I have Ola with me, Ola Pettersson from Epiroc. We will talk about AI in mining, the Epiroc perspective. Ola holds a PhD degree in artificial intelligence from Örebro University. His research interests include autonomous mobile robotics, fault detection, and signal processing. His current position is manager platform development at Epiroc Rock Drills, Örebro, Sweden. He is responsible for the automation platform, that is the core control platform used in all Epiroc's computerized machines. He is often involved in various research projects within robotics together with academia. So welcome, Ola. So we will hear a little bit about how you use AI now and what you do.
Yes. Yeah. Thanks a lot for the not so short bio I recalled. So this will be a super short glimpse into how we're using AI at Epiroc or in Epiroc's machines and services. And maybe you should first ask yourself, why should you bother about AI in the first place? And this is, of course, that you can increase safety and health. You can, in many cases, get people out of the mine. So that's one point that I will discuss shortly. But you can actually also increase ore production and in many cases save time and money as well. But first of all, I would like to show this picture taken from a paper given to the European Commission, actually, as an introduction to AI or a definition of AI. So I often read papers on deep learning, that deep learning is AI and machine learning is AI. But I would like to widen the term a little bit here and claim that it's not only machine learning, it's also reasoning and robotics. And I will talk a little bit of each of these three areas. And since we are a machine company, we start with robotics. So this is one of our loaders that is now running autonomously. And here it is, of course, a lot dealing with censorship and getting the right sensors that can deal with this unfriendly environment. So we need to find the good stuff that is robust enough operating underground in this case. Not maybe so much on the algorithms themselves. It's not the latest and greatest when it comes to AI research on the algorithms, I would say, but it has been a long journey getting things robust. So, and we have been doing this for some time. I think the first loader sold was in 2008. if we move on, so this was actually a little bit discussed earlier from Federico. So when we have these fleets of autonomous rigs that actually cooperate, we need to use something else. So here we introduce reasoning. We would like to plan and schedule. And I would say that this area of AI is more important when you want an optimal solution. So you don't perhaps have a lot of data and you really want the machine to be used to its extent, to use it as much as possible. So in this case, you have 4 big drill rigs and you want them to drill all these holes on this area as quickly as possible. You can optimize on many things, but most often it's time. And as Federico said earlier, Ola will show the cool movie, so I will do that. So here we have a number, it's 3 pit vipers, and they are given the same task, drill all these holes. So the fantastic algorithm actually made in cooperation here with Federico. So this is Federico's movie actually. We can plan what drill rig should drill what hole and in what order, and when things happening. And this is also connected to what Håkan and Federico discussed earlier. There will come a white screen soon here. And what happens is that we kill one of the machines, we break it. So the middle machine is now not useful, and the algorithms needs to cope with this and replan. So as you see, the machine number 3 there moves on with what number 2 should have done. Cool. But of course, yeah, we need still machine learning as well. And I would say when you have a lot of data and it's not super easy to find models to it, then this is really interesting. So we have research going on in predictive maintenance. So we have a guy, a PhD student at Linköping University that has spent quite some time on this topic. And the idea is, of course, to gather a lot of data in order to make conclusions on when a machine will break down. So he has done a tremendous work on this. And as you see on the picture below, one of our trucks, he put a lot of sensors on the machine in order to get a good data set here. And then he has made a lot of models, both white models, understandable models, and also more into machine learning algorithms. And another, this is my last slide, when you have tried other things and it doesn't work very well, then we also introduce machine learning. So one thing that we have been working with for such quite some time is filling the scoop autonomously. And you can do that with expert systems, you can do it with pre-compiled movements, or you can do it in many different ways. So here we have had one project with Queen's University, more of a traditional control theory approach. We got some results, but then later on when we tried another pilot, it didn't work well. So now we are also exploiting, working together with Algorix, a company in Umeå, and here it's more of a brute force machine learning, a lot of data, and try. So that's kind of this short introduction for me.
Yeah. Hello, Jan. You're
Hey.
from ABB. And I have a short introduction for you.
Mm-hmm.
So John, for control and optimization in mining, but also robot applications. He currently holds a position as Global Product Manager for Automation and Digital Underground Mining at ABB.
That's correct.
Yes. Welcome, and you have a presentation that you can share, I think, from this computer, from the computer you're at. Should I have a look? Yeah, but I can't see it in. Can the audience see it? I don't know. I can't see it here in my the Swedish Mining Innovation. Oh, it's not shared. It looks like it's shared. Maybe from. Oh, that's why.
Okay.
Yeah. Yes. Oh, you can if you have it in presentation mode. Yes.
Mining, is one of them, of course. We have actually last year we celebrated 130 years of mining, so we have been there for a long time and trying to follow the technology as far as we can, and sometimes we even lead it. Our core, one of the core, is of course automation and control of processes. That is our one of the biggest core we have, and to follow in AI is in our core automation system is continuous. There's a lot of different connected devices, of course, and also a lot of information and data available in this system. And here we would like to help our customer to make use of this data and this information and improve the processes as well. So here we introduced our new industrial analytics and AI suite called Genix. So this is the recent launch. And here we can make use of all the operational data, but also other kind of data sources like engineering data and also IT. Looking both in analytics, but also have a lot of different kind of machine learning algorithms, but are predefined as well. This is an open system. We can both have a lot of predefined functionality. Most of them is also very industry specific, but there's also an open system so that our customer can develop their own algorithms on their own analytics as well as they want to. And here we take care of the full functionality, capture the data, model the data, get the data for different sources, but and creating the model and put that in a context. But we can also train the model as well. Up in the cloud, we train it, put the models back into the control system, so we can also run it directly on the process we would like to control in a more advanced way. One first example here is that we have created what we call it energy awareness. And this is for the mining customer that we connect different kind of sources like to capture the energy consumption for the power control, but also for diesel machines. We also can collect the production data from both from the planning, but also what is ongoing right now, and also have actual spot prices. So we can put a price on the energy as well. And here we can monitoring everything in real time. And that can be done in different levels for different mines, of course. And this is a good way, first way to start to be able to do AI on this as well. So that will be the next step. But at least we have the model, we have the data in real time. One example that we really use the model to control and process. This is a typical for mine ventilation. Mine ventilation is a huge energy consumer underground. 50% of energy used underground is to ventilate the mine. The challenge here is, of course, the size of the mine. It's a lot of space that need to be ventilated, but also that the operations is done in different places in the mine, and this is shifting all the time. So we really would like to only ventilate where it's needed. And here we use the traditional automation as a base. And with that, we can push the air that we would like to have it. On top of that, we have a model-based control that we can run all the fans in operational optimal set points to really minimize the energy. And typically energy saving that we achieve with this one is 20 to 40%. But this is a model that we extract directly from the operation data and can put back and control it. This is an example of one small process. Otherwise, we take a little bit bigger perspective that we try to really look into the full value chain. There we have several processes, and here we more talk about global optimization. And this is one case that we have built a model for the material flow for the full value chain from the first phase that we have extracted ore to the port that we are shipping it away from to further processing. Here we developed the first digital twin of the full value chain. We also have the simulators. So we can start to kind of data source and software we have integrated to the models as well. Now we are on the phase to we have identified a couple of use cases. We also connected that to different machine learning algorithms. So that is the ongoing project now. So we will start to look into that as well. Another ongoing project is the development we're doing right now is the robot charger. We call it robot charger. Here we try to have the operator that are charging the tunnel phase of the explosives. The operator is working in an unprotected area. It's also quite heavy work. And this is something we like to support them to move them from the unprotected area and maybe work more remotely. And the solution we are putting in here is one of our industrial robots that will do the manual work or replace the person in this area. With a robot, you need to program it. You need to tell the robot what to do. And the challenges you have in mining is that you're moving to a new phase all the time. So in some way, we need to replace the robot programmer. And here we're using a vision system that consists of the network model. We're using a network model that are actually replacing the robot programmer. The network model is using image that are captured by the camera. I'm using also machine learning to train this network model on these several images as well. In this way, we can identify the hole to be charged. Position also in second position. I will just end this presentation just to show one good example that we really have this in place. And this is a short movie from our lab. Right now we are testing this on site several times as well. So. This is just showing the speed that we can work today. And the enabler of this is AI. Without this, we can never do it. Okay, that's all. There were some examples.
Yeah, thank you. Actually, I had a look at your presentation yesterday when you sent me this, and I was going through it, and I had my 9-year-old son standing behind me, and he was just like looking at the presentation, and then this video came up. Oh, what's that? So it's kind of cool.
Yeah, that's cool. It's looking even cooler in the mind.
Yeah. Håkan, some more from LKAB, what you are doing right now on projects.
Yeah.
Yes.
Okay. We talk about some examples from LKAB. What we are doing with AI. We have started with what we think are the simplest. That's taking pictures and doing analysis of the pictures. So we have a lot of video cameras. So we take the.
I think it's not shared. Sorry. Presentation mode. Yes.
Okay.
Perfect.
So we have started with what we think is the simplest one, and that's you analyzing pictures with AI. And one example, we when we dig in the tunnels down underground, we have to check the map, the tunnel, and see if is it iron ore, is it waste rock, or is it some cracks. So we have put an AI in a mobile phone, so you don't need to be a geologist to do the mapping, and you will see the result directly in the phone because the AI is running in the mobile phone. In our pellet plants, we're looking into the oven in the pellet plants. So you see the picture of the oven, the yellow one, that's roughly 10 meters across. It's flowing pellets in a constant flow. But in the flow, we have some sticky slag that will prohibit the but we have not any measure, just looking on the picture. We want to measure it so we can make a soft sensor so we can use in maybe detect why we have slag buildup. So we have an AI doing that, taking the picture, sending it out to our AI in the cloud that doing the analysis, and sending it back to our historian that we can correlate it with the other sensors from the plant. And the operators also see the trend of the slag buildup. In one plant, because in the first one we only have one picture, now we have 2 cameras taking a stereo picture. So we're trying now can we predict the volume with an AI? Because in the other case, you only see the area. And these slags can be very heavy. They can weigh up to more than a ton. So they can a maintenance problem if they fall down from this. And also we started up to look from the historian. Now when we have measuring the slag buildup, then we can look on other thousands of sensors that we have in the plant. What's the root cause? Can we find it out? And we store a lot of sensor data. So this is from the plant. This picture don't look so nice, but and you can't see it's too small. But it started 2008 when we started the plant. So we have not dropped any sample yet. We are sampling the plant every 10 seconds. We are storing the samples. So we have data more than from 2008 today. So it's a lot of data. We have tried it on predictive maintenance. And predictive maintenance is very difficult. We have tried this as a commercial AI, and we were not able to make it work. It looked promising, but when we tried to put it in production, it was too many false alarms in it. So it's a predictive maintenance everybody talking about, but it's a very difficult area. Then we are doing some R&D. And this is our rock breakers in the mine. So it's made from our CAD drawing from the rock breakers. And the rock breakers is not just a graphical model. It's a model. It's a dynamic model. So the exact handling and the weight and everything of the rock breaker are simulated in this. We try to make the AI to hit the black rock and break it, because that's a problem we have in the mine. So this is really funny thing to do. We train an AI and you can visualize it. So we have a gaming visualization, and we have trained that and with a simple way of making the model. So this model and this presentation, everything took roughly one to 2 weeks from a CAD drawing. So a lot of nice tools are coming now. So it's the speed you can do things with is increasing. This is early stage because it's not so easy to put this solution in production. So summary, we're doing a lot. We try to put them in production, and we don't want to do proof of concept. We want to plan for production because it's very difficult to get from the promising proof of concept to production. So that's super important when you start from the beginning to plan for production when you decide your solution. And we think it's important that the business, the IT, and the digitalization team that have knowledge of the new tools like AI and machine learning are in building everything together. So solve real business problems. And in many cases, you try to use solutions to use AI, ML. The business, they are very happy if you solve the problems. They don't, the tools you use, they don't care about that. So plan for production from start. I think that's super important if you want to achieve production. And challenges when you start to dig into this, that you see that data quality, because AI is a kind of automatic decision making. And if you don't have good data quality, you will have poor results. And then when you have this solution in place in production, the governance of the solution, that's very important. Otherwise, because you need governance. This is like advanced models we have been running for years. If you don't have governance of the model, they will not fulfill the goals anymore, and we will switch off them. That's happened in many cases with advanced models that we are running in the plants. But now it's the same problem with AI. We have to have the governance. So that's if you plan for production from the beginning, you will have the right people into the project. And to the end, it's simple. The technology is simple. You can buy solutions, but this will change the way you're working for people, and that's the difficult part. So you have to plan for that from the beginning and take everybody on the journey from the beginning, so they are aware of what's happening, and you can have a lot of good input. Because many times you think things are done in a certain way, but when you really look into it, it can be a whole other business. Okay, some shorts what we are doing.
Yeah, thank you, Håkan. Really interesting, and it's quite interesting to hear. You have the very similar challenges as with Lundin, as Kira told us, and also that David Degerfeld will talk about now the governmental and the people and how to implement this in the organization.
Yeah,
it's really interesting. So we will have video with David Degerfeld from Boliden. He's a program manager, artificial intelligence in mining. And I think it should be ready to start. Yeah, great.
Thanks. Yeah, hi, I'm David. I'm working with the Boliden Mines. I'm the program manager for a research program, Artificial Intelligence in Mining, that we have been running for a little over a year now, with the tasks to enable artificial intelligence and digitalization throughout Boliden. And I would like to talk to you today about our strategy for enabling artificial intelligence. So, but first I would like to share this slide with you. I think you've seen this before and are probably very much aware of this maturity model, but it's very good to identify where we're currently at. It has been surprisingly accurate and relevant and helpful in our way forward. We're currently somewhere around level 2, I guess. We've done quite a lot of pilot studies. We've done the initial proof of concept, proof of value, and we're also considering the impact on our people, processes, and technology. But we want to move ahead. So how do we get ahead to level 3, to the integrated level? And looking at what's listed under that box is integration with operations. It's this big decision on platform infrastructure and what skills that will be required. There's also mentioned the AI architecture, and it's also mentioned that a strong vision is needed and that you need to work with change management. And this is absolutely true. This is something that we've realized. So how will we do this? Well, for us, we need to sort of look back and see where we are. And And this is sort of a view of our challenge, the legacy. We have, I mean, we're a pretty old company. We have a big organization, and we have been very successful at implementing various support systems, like control system for our process. We have also other systems like for procurement, HR, laboratory information system, product management, maintenance. Essentially, we have IT systems supporting each step of the value chain. And what is happening now with digitalization, artificial intelligence, is that we want to combine these systems in a much more integrated way than what we have done traditionally. I mean, we've for a long time been able to open up drawings directly in our control system. That is nothing, but this is something completely different. These systems should be more aware of each other. And the challenge is not to do that integration. It is that we have optimized our organization for these systems. So it's not only an IT question, it's how people should work together across traditional boundaries. So the strategy we have sort of ended up in, or where we find ourselves now within the artificial intelligence program, is that we should work with these three main areas. The first and most important one is the inspiration. We need to inspire everyone in the company to actively participate in activities in artificial intelligence. We don't believe that we in our research program can solve anyone else's problem. What we can do is to provide expertise to help our colleagues that have never worked with artificial intelligence before to make use of the technology. And for us to be able to do that, we need the platforms and the tools that support these kind of solutions that can work across all these traditional systems that we have. So currently, we're doing quite a few proof of concepts, ranging from image analysis projects to more pure raw data and pure artificial intelligence projects with neural networks and classifying and really interesting and cool stuff. But the most important, or a lot of focus we're also putting on now, is to build up an architecture in our IT solutions that would support rapid and dynamic deployment of various solutions. It should not take long from an idea until we can deploy an artificial intelligence solution in the cloud or in an edge computer somewhere. So the conclusion from this is that the strategy that we're working on is not a strategy for artificial intelligence at Boliden. It's how we should work at implementing it, because the strategy needs to be embedded in your corporate strategy on a very high level in order to succeed, to be able to build this collaborative and change the way we see our systems. So that, I think, is a key for success. It will be, most certainly will be a key for us at Boliden. Okay, that's the end of my talk here. Thank you.
David. So we will move over to Down Under and welcome Ali Sofastei. Ali is a global artificial intelligence projects leader who's been involved in industrial research and development projects in several industries, for example, mining and steel and oil and gas. And are you with us, Ali?
Yes, thank you so much. Can you hear me?
How are you?
Not too bad. Thanks for asking. And I'm sorry for the technical problem that I had in the beginning of the session to join you.
Yeah.
So, but I'm here right now and I can start. Can you see my screen?
Yes.
Perfect.
Yeah.
So the title of, yeah, I need to just, jump between the slides to make sure we can cover everything just in 11 minutes, hopefully. So the title of my presentation today is about AI applications in the mining value chain opportunities and challenges. I'm Ali Soufastai. I'm an artificial intelligence program leader in Vale. As you may know, Vale is one of the largest iron ore producer in the world, and we are the biggest producer of nickel. Around 30% of consumed iron ore in Chinese steel market is provided by Vale. Vale has been ranked as 19th innovative company between all companies globally. And it's the good achievement for Vale when we can see Amazon, Apple, Microsoft, Samsung in this list. And with the huge difference, Rio Tinto has been ranked as 49. Everything related to this rank is coming back to the management and to the decision to use digital transformation and using AI for optimization. Vale is one of the mining companies that they have the spatial center named AI Center, focused on using AI through the mine value chain. And now we have different projects through the mine value chain from exploration to marketing. AI Center physically is located in Vitória. Vitória is the capital city of Espírito Santo in Brazil, but all my colleagues working globally from everywhere. And we have plant, office, and mine site in more than 35 countries in the world. So one of the best approach that we have in AI Center is working directly with universities and research centers. And I believe that the good achievement that we had for digital transformation coming from this approach. And now we are working with more than 20 universities directly across the board, especially in North America and in Europe. The scope of AI Center work is finding any opportunity to develop AI solution to solve the business problem through the mine value chain. And we have some exciting project for exploration, for example, for marketing, for mining, for environment, and for community. And we believe that reaching to the mining 4.0, it's possible when you can develop your application and having the integration approach to integrate all applications through the mine value chain. We believe that digital transformation and using the AI application is not just a platform, it's not just tools, it's culture. And to change the culture, we need to focus on multi-dimensional purposes such as resources and capabilities, research and training, and governance and methodology. And in this slide, you can see 4 main group of activities that we are following up in AI Center to not only develop the applications that we need, but also train the people thinking about the governance, sustainability, and developing the scalable products to use in different mine sites. This is the research and development workflow, but it's very simple here in this slide, but in the real life, it's not simple, it's very complex. But in AI Center, we try to follow this chart. Everything is coming from the businesses that we have, coming from mining processes, railroad, pelletizing, ports, and other operations that we have. We are receiving these business challenges as business problems, and we are gathering all of this in the innovation hub, and we evaluate our capabilities and the concept of the problem. If we found any potential AI solution for that specific problem, we go to the planning phase and we make a plan. But in the heart of this workflow, you can see the box named research. And in the research box, we are working with OEMs, universities, technology developers. We really like to outsource or research, and we like to share our business problems with some researchers across the world to find the best solution. After finding the solution and having the validation, we will work with our partners, same as Microsoft, Accenture, Deloitte, to develop the final product, and we will deliver the product to the industry, into the businesses. And here in the middle of these processes, AI Center not only lead all AI projects, but also after completing the product, we look after the project for any enhancement, improvement, or maintenance. But one thing that is important to extract the benefit of using AI in mining industry is thinking about AI maturity, because I told you that using AI or using any advanced analytics approach is a culture. You cannot jump to this deep ocean. You don't have, it's necessary for you to think about all dimensions and all aspects of this problem. As you can see in this slide, we have around about 6 levels of maturity for advanced analytics. And unfortunately, all mining companies located in the sense and respond area. It means that they are sensing the problem and they have respond and they are thinking about a solution. But AI and advanced analytics potentially can help mining companies to transfer from sense and respond area to predict and act when we have prediction and optimization models. So in this slide, you can the simplified version of the maturity scale, and based on the 6 levels that I explained for you, you can see from dark orange to dark green is the different maturity. And you need to think about data, people, system, and process. And you need to clarify all dimensions that you have for each group. You can define these dimensions by having your brainstorming session or workshops internally, but it's important to reach to the balance between the maturity in all dimensions here when you are thinking about having the sustained AI approach for your company. So for using any product, any AI product, you not only should clarify your as-is situation, but also you need to clarify what exact point of maturity you need to use the product. And by plotting 2 graphs here, for example, red graph shows as is and the purple one shows to be situation for you, you can clarify the gap between your current situation and your to be condition. And by making a plan, you can cover this gap for each dimension for each group individually, and then you can use the sustained AI in your company. But it has just 2 levels of maturity scale. The low level of that is focusing on data, process, people, and system. But in the high level of maturity scale, you can see safety, energy efficiency, maintenance, and operation. It means that AI can give us some benefits and can make some advantages for us when we have the mature system and the mature people and mature mature data for safety, for energy efficiency, maintenance, and operation purposes. Completing this type of the maturity assessment not only can help you to use AI practically for your business, but also it can help you to complete some benchmarking. The big mining company, same as Vale, has a lot of mine sites. For any new investment for digital transformation, we need to clarify which mine needs which type of resources. For example, one mine needs to focus on data, another mine needs to focus on people or something like that. And by completing this assessment, you can plot the graph same as this, and you can find any new investment to go to the AI edge or digital transformation programs. Vale now is using this approach, the maturity assessment, and we are using the very sophisticated models. As you can see, this slide is the screenshot of the application that we are using. You can just click on the year and you can click on the region and you will reach to the maturity of data, people, system, and process in different areas. It's very important and it's very practical. So we know that we are very young in this area and our students at universities need to have more study, but we don't have enough resources and publications in this area. So in the last 15 years, I tried to gather some researchers globally to publish some books in this area. And now we have a couple of reference books available, and I can suggest you and other researchers who are interested to study about advanced analytics or AI application in mining to read these reference books. All of the books are available on Amazon or other platform. All right, thank you so much. And thanks for giving me this opportunity to present something about Värde AI Center and our methodology to use AI practically in mine value chain. Thank you so much.
Great, thank you so much, Ali. And we saw your contact details. So if you have any questions for Ali, please just go ahead and contact him, I guess. Okay, Ali.
Yeah, sure, thank you.
So we won't have time for questions for you, but I was thinking maybe you could have a couple of questions for this discussion group here, our first panel discussion. We have Ola Pettersson, who you already met from Epiroc. We have Mats Tallfors from RISE. And we have Ivar Simonsson from Epiroc Mining Intelligence. And just very short, Ola, you know already. Mats, he's a researcher in AI and machine learning at RISE with skills in, for example, dynamical system signal processing, optimization, applied mathematics, a lot of things. Previous experiences from, for instance, ABB include hot flat steel rolling models, automation in mines, and sawmill automation. Yes. And Ivar, you're a data scientist, holds a PhD in mathematical statistics from Chalmers, doing research within the Next Gen SIMS project, an EU-funded research project for sustainable and intelligent mining systems. Welcome, all of you.
Thank you.
Thank you. And Ali, is there something you would like to ask this panel? What are the challenges for the mining industry, AI-wise?
Yeah, one challenge that we are facing with that is developing the integrated systems and also having access to the appropriate data for different operations. It's the two big challenges that we are facing with them, because for some simple operations, same as holding, loading, or crushing, you have access to the huge data set and you can do many things. But for other areas, we are facing with the lack of the data. It's the big challenge for mining companies. There is not any balance between different operations to have access to the data. And another problem is that all the startups and the IT companies try to focus on some specific areas to develop some specific application. But we know that all operations in the mining industry are linked together. And you cannot just focus on one area. We cannot develop one application, for example, to optimize the hauling operation, because any change in the hauling potentially can affect on upstream and downstream operation. Okay, so this is the challenge that we have. We have many AI applications, but focusing on just is to solve a specific problem. And we don't have integrated applications right now in mining. Some companies started working in this area, but we don't have the practical, successful products. So this is the two things that I think is important for mining in the mining 4.0.
Great, thank you. Someone anyone who would like to start? So the integrated systems, and maybe if we can take the ecosystem for AI in mining for the next panel, maybe, and we can discuss a little bit more about the integrated systems with you guys. Anything you have listened to earlier during the webinar that you
I think he was concerned about that the data is not available in the right place, and I think that is important. That is true, and especially if you kind of think and hope that everything will go to the cloud and you have everything cleaned and time stamped and in good order already there, then you will fail miserably, because you don't have that chain all the way up to the cloud easily. And there are so many things on the way before you're there. So if you have an underground mine with poor Wi-Fi connection, the data stays on the machine. And so I think there is a lot to data communication, wireless communication, and things like that before you can start working on your huge data set. And I would say that's quite often where we get stuck. And then, of course, you get all this proprietary thinking as well. This data is mine, this is yours, this is mine, this is mine. And then you cannot make even better conclusions when you can combine all the data. So yeah, that's my take on it. So yeah, we need to get better communication from the machines and from the mine somehow.
Somehow,
yeah, we need to include. There should be.
Yeah. I mean, we can
Cisco in the room.
we can always like work on increasing connectivity, but I think in the end of the day, you can sort of escape from trying to make the computations on the edge as well.
Yeah,
you can't just send all the data up to the cloud all the time. It's not sustainable. I think you need to focus more on doing edge computing.
Yeah, I agree. Yeah.
Also, my experience, I've been working with data from process industry for a while, and in general, they have a lot of data, but the information in the data is very poor. So it's very good if the people working on the AI have a good knowledge about the process they are working in and understanding how to take out the important information and to filter out the thing that is just noise or disturbances. So the more I work, the more I see that you really have to understand the data. Even if they say that data-driven models, they don't need to know the concept or things like that. That's not true. If you have a lot of data, then there's not a problem, but then there's a lot of good data, so to say. But in general, the hard work is not to find the right AI algorithm. It is to dig out the important information in the data when you work with data such as that is available in most process industries.
Yeah.
Yeah, very good points.
May I say something, to complete this discussion, because I believe that is important for us to focus on the business understanding first, because we don't have the good business understanding. We don't know which type of the problem can be solved practically by AI. We are just collecting the data, and we are just saving a huge amount of data in a data warehouse or in the data lake. And then we try to dive to the data and to find insights. I think it's the wrong way, because it's a time-consuming and it's very expensive way to find AI solution. But if we could focus on the business understanding better to clarify what exactly we are looking for that, and then try to find the AI capabilities right now, because we are living and working in the age of weak AI. We can't speak about the general AI now. AI is not magic right now. AI is the simple machine learning that we are working with them. So we need to clarify our capabilities. We need to clarify the business requirements. It means that in the middle, we need some unicorns. Unicorns are people who have the business understanding, he have a background, for example, in mining, a mining engineer, and in other side, they know something about data mining, and then they are familiar with the AI capabilities. These unicorns play a role as a hero to clarify how AI can help mining industry for any improvement or optimization or making better decision.
But then I have a question for you. Do you think that the mining companies should stop saving everything they get their hands on? Should they start finding the right data, or how do you? What's your take on that? Because I think the companies are afraid of missing out. They save everything because maybe in future we will get something there hidden in the data. So that's why they just fill up their disks.
No, this is a traditional approach, okay? Traditional approach. And one thing that is important here is having some companies and smart startups who are making the different sensors, because we know that the technology of making sensor has been, grown up very well. And now you can find many different types of sensors in the market. And they advertise their product and they encourage mining companies to install new sensors and collect the data and something like that. But it would be, one challenge for mining companies, the big data challenge. We really like, it's necessary for us to know which type of the data should be collected from which component or which area. It's important. It should be done in the beginning, and then you can order the data. I think it would be the better approach. And in Valley AI Center, we are working in this area. Instead of just installing a huge amount of sensors and collecting the data, we try to find, okay, which type of the data do we need from which area for each component? But it doesn't mean we need to stop collecting the data. We need to just customize this approach, and we need to just improve this approach and making the best way to reduce the cost and also maximize the benefit.
Mm-hmm. Thank you so much, Ali. Great. I would like to welcome the next panel. So
sure. Okay.
It was quite a short visit here for Mats and Ivar. But we need to move on.
Okay.
Yes.
Thank you. Thanks.
Thank you.
Yes. Thank you. Bye.
And you can send the rest of the people in here, and I start to introduce them.
Okay, so I think I need to drop off the call. Thank you so much for having me. Thank you so much. I really enjoyed. Thank you. Have a great day. Bye-bye.
Bye.
Bye.
So, hi.
Hi.
You have waited for a long time. So, Jan Ekman from RISE.
Yes.
Yes, and Madeleine Martinsen from Mälardalen University.
Yes.
And Jan, you already know from ABB. I will just introduce very short Jan and Made. Jan is a researcher in computing science and has contributed to many projects with statistics and data analysis solutions. He's currently participating in a project on permitting processes, where one question is what improvements can be achieved through AI solutions. I think this is really interesting. Madeleine, you're currently a PhD candidate within the Future Energy Center at Mälardalen University. She has more than 25 years of wide competencies from engineering, internal auditing, controlling to management positions within both the power and automation industry at ABB, including abroad assignments in Germany, Ecuador, USA, and Denmark. Welcome.
Thank you.
Thank you.
Mm. So what do you think about the discussion so far?
Interesting.
Yes. any ideas, new ideas, or that have arisen in your heads? No.
Concerning which question?
No, but I think it has been really great afternoon with a lot of interesting cases and examples, and I will bring that with me to continue my PhD and see how I can incorporate that into my cases. I have currently working a lot with image recognitions. As you know, I send in a drone in the mining mill and try to inspect all the objects instead of having to send in humans. So there's a lot of safety issues in this. So I liked Ole's first picture when he says, why are you going to have AI? And he had safety on the first line. And this is my concern as well. How much can we use those kind of machine learning tools and AI applications instead of having to have humans for dangerous works in the mines?
Yeah, I think when I went through different AI applications, and I was thinking about how it all applies to the value chain, and I was looking at our program's aims and ambitions about how to make things better from exploration to social aspects, and I realized that everything we do is for having a safe and attractive workplace. And I think AI solutions are really, or AI tools are a big, it's making things possible.
Yeah, it will definitely contribute to it. Yes.
Yes.
So one question is, if we are thinking about what future society we want, do we think about that when we develop new solutions, or will it just become something that we didn't expect or expect? That's one question for us.
The big plan.
Yeah, what's the big plan, and who has the big plan?
Yeah.
At the same time, we have so big challenges in front of us.
Yes.
From the climate point of view, of course, that is the biggest one. And the big step we're doing right now to really electrify all the processes mining, that will really push the technology there. I mean, you can't stop it.
Yes.
We need to follow it. We need to solve the problem. So that will be the push.
Yeah.
And the most interesting thing, and a lot of interesting thing here is that now we're starting to do things. We do a lot of things. We have it in the operations. We also, at all companies, also have this as a strategy. So it's there.
Yes.
And the driver for that is these big challenges, the big steps we need to take from the technology point of view for the future.
Absolutely. Yes. So what will you take home, Jan?
Yes, I will take home
Yeah.
that. A lot of the discussions I've heard today are very similar to the discussions we have in our company. So I will take that with that people are reasoning the same way in many places concerning data and the challenges and AI. That's what I.
Yes. And Maddy, you will implement maybe new ideas in your research.
Yes, we have some ideas what we can do in this Sustainable Underground Mining Academy project for safety, especially when it concerns fires, since we have nearly one fire every week in some Swedish mines, and 80% of them are started by the mining vehicles. So we are trying to find out the solution for how can we do some kind of quick health check on it when it goes out and in, because it goes up and down, and those mining vehicles, we could have some kind of image recognition, but also we could measure the temperature on, for example, heated areas or wear out tires and so on. And from there on, we could support to say, you need to go and change the tires, or you need to do some change of some hydraulic oil is leaking or something, or You need to take care of the cables or something before you go down. And I think this could reduce number of fires, but also then in that sense, you will also keep up the productivity. And that's most the concern, to have a high productivity in these days.
And the safety.
And
safety
the
first,
safety
yes.
first. Always safety.
Yes. And Jan, do you have any new ideas that you will take home to ABB? Maybe together with the LKAB and Madde here.
I mean, it seems to be an open field to do things.
Yes.
And then the nice thing is that everyone is starting to talk about it. Everyone's starting to learn what it is.
Yeah.
You also start to get the tools. I mean, the tools to be available for everyone, and then that shorten the time to do things and so on. So I mean, everything is talking in this or driving us in this direction and help us. I mean, that is conclusion absolutely from this day as well.
Yes. So it's 5 minutes past 3 actually. So I think those were the concluding words from this panel. And we will end this webinar now. And thank you so much. And thank all of you who has joined us. And the webinar has been recorded, so it will be available. You just have a look at our website, Swedish Mining Innovation, and you will find it there in a couple of days. So thank you, Susanne and Isabel behind the camera, and goodbye.